do some basic operation of signals. So far, we have discussed elaborately continuous time signals, and to some extent we have discussed about the discrete time signal also. But we will try to study the basic operations on continuous time signals first, and then we will extend the same concept to discrete time signals. So the first basic operation is time shifting. So what is meant by time shifting? Suppose we are having a signal. Let us say I'm having a signal. Let me draw a signal. Let us say I'm having some signal which is having the following shape. Let me call this as x of t, and this is the t-axis. This one is the x of t axis. Now, if I want to shift the signal in the forward direction, suppose if I want for some application, I want to shift the signal forward. Then suppose let us say the signal has been shifted to t0. Then the x of t becomes x of t minus t0. Suppose if the same signal is shifted backward, this is called delaying in time. We are trying to delay the signal. Whereas if we try to shift it backward, suppose the same signal we have tried to shift it backward. Say, let's call this as t0, negative t0. Then this can be represented as x of t plus t0. So here I am trying to shift it forward, and this is called advance. This here I have delayed it, and here it is advancing of the signal. Okay. So there are two. We have seen what is time shifting, and let us try to do it in this is continuous time. The example is in continuous time. Let us try to do it the same thing in discrete time. Suppose if I'm having, let us say I'm having a discrete time signal. Let this be okay, and then let us say I'm having something like this 1, and this, let me call it as, okay, this is 1, this is 2, this is 3, and this is also 3. So let the index be 0 here, 1, 2, 3, so on and so forth. So negative values are having 0 sample. So all these negative values and the value and the samples for n greater than 3 is all having zeros. Okay. So there are only 4 samples here. The first sample is having a magnitude of 1, second is having a magnitude of 2, 3 and 4, so on. Let us call this as x of 9. Suppose I want to shift it by 2 units. So let us say I am going to delay the signal by 2. Delay the signal by 2 units. The delaying means I have to shift it forward in the forward direction. So the new signal that I get is, so this is your y-axis and x-axis, 0, 1 and 2. So the signal that was here, the sample that was here will be shifted here. Okay, so now this will become 1, and at index 3 the sample value will be 2, and for index 4 and 5 the sample values will be 3. So here in this case we have shifted it by, and this we have to call it as x, n minus 2. That is, we have delayed the signal by 2 units. So that means we have shifted the signal in the forward direction by 2 units. Now let us say we are having, we want to advance the signal by 3 units. Suppose if I want to advance it by the same signal, I take the same signal, this signal, and then I want to advance it by 3 units. Okay. Let me try to draw it out here. Okay. So if I advance the signal, when if I try to advance this by 3 units, now the first sample, which was at index 0, will be shifted to negative 3. Okay, so this will be 1, and then you will have 2 here, then you have 3 and 3 here. So this will be minus 2 minus 1, and this will however be 0. So this is how the signal is going to be after it is being advanced by 3 units. So this I can represent it as x n plus 3. So let us now what we have seen is the time shifting operation. That is what we have seen both for continuous time as well as for discrete time. Now let us take the next operation. Let us try to discuss the next operation, which is the time reversal operation. So in the case of a time reversal operation, let us take an example. Let us say there is a signal of something of this nature. Okay. Some kind of a triangular wave shape. Let the peak occur at 2. There is 1, 0, and 3. So if I want, this is x of t. So time reversal is, we consider the y-axis as a mirror and try to do a mirror mapping, okay, along the x-axis, along the y-axis. So when we do that, when we do a time reversal, after the operation is done, we get the following signal. Okay. So it will be something like this. So this will be negative 2, this will be negative 3, here I will have negative 1 and 0. So we considered the y-axis as a mirror, and then we have reflected the entire wave, the wave shape, on the mirror, and on the other side we got the mirror image as what we see here. So this we call it as x of negative of t. Okay. So this is known as the time reversal operation. So if I have done the time reversal operation, and suppose if I want to advance it by 2 units, suppose if after doing the time reversal and I want to advance it by 2 units, advance in the sense I have to shift the signal in the negative direction. So if I try to shift the signal in the negative direction, the signal will become, let us say I want to advance it by 2 units. Okay, so this will be negative 2, negative 3, negative 4. So my signal will become like this, and you have negative 5. So this is 5. Okay, negative 5. So the signal, the way I represent this is, it is negative of t and negative of 5. Okay, so x of negative t, negative 5. What I have done is I have done a time reversal. The first operation was time reversal, and the next operation was advance it by 3 units, by 2 units, sorry, by 2 units. So it has been advanced by 2 units, negative 2 units. Okay. So this is I have done both the operations. First was the time reversal, and then I have done the time shifting. Suppose I take this signal and then try to delay it by 2 units. Suppose if I want to delay it by 2 units, what will be the wave shape be like? So in that case, if I want to delay it by, let us say, 2 units, so the wave shape is going to be something like this. Okay. So here I can write it as negative of t plus 2. So here what I have done was an advance operation, here it was a delay operation, and here we have done a delay operation. So this is the second operation that we have seen now. The same thing we can extend it even to discrete time signal. Maybe we can take an example. So let us say we are having a signal or something of this nature. Let me draw the y-axis and x-axis. So on the x-axis, I am having a sample value. On the y-axis at n is at the index number 0, I am having a sample 2, and at 1, let us say I am having a sample length or sample magnitude of 3 by 2. Then at let us say 2, I am having a value of 1. Then again at 3, let us say we are having a value of 3 by 2. Now this is x of n and this is n. Suppose if I reflect it along the y-axis. Suppose I reflect it along the y-axis. After reflection, after the time shift operation, the time reversal operation, the value that I will get here I will still have at 0, when n is equal to 0, I will still have the sample value of 2, and at n is equal to minus 1, I will be having 3 by 2, and at 2, I will be having 1 minus 2, and at minus 3, I will be having 3 by 2. So this the entire the samples got reflected, that the mirror imaged, and the image is actually as follows. So we have done a time reversal operation. Now I can do a time advance operation. Let us say I want to do I want to advance a signal. I want to derive the signal, which is advancing by 2 units. If I try to advance this by 2 units, at negative 2, I'll be having I'll be having 2. At say negative 3, I'll be having 3 by 2. At negative 4, I'll be having 1, and again at negative 5, I'll be having 3 by 2. Similarly, we can do sorry, this one is advance operation, so I should have put a negative sign here. It should not be a positive sign. So it is minus n minus 2. That is, I have done an advance operation. So if I can also do a delay operation, which I think the viewer can try by himself from the example that I had given in the continuous time case. Let us take a few examples. Let us try to solve the following cases. Let us try to sketch the following sketch the following signals. I want to sketch, the first example is u of minus t plus 1. I know that u of t is the signal u of t will be like this. So it's a unit step, so this will be having a value of 1. The amplitude of the signal is 1, and it will be having only after t greater than 0. So only the signal is present only after the time t is equal to 0. So if I want to do this signal, first I have to derive minus negative of t. So the negative of d will be something like this. All that I need to do is I need to reflect the signal on the y-axis. When I do the reflection, after reflecting, the signal that I get is this u of negative t. Then I will have to advance it by 1 unit. So when I do that, when I try to advance this by 1 unit, so it becomes like this. Okay, so it is minus t plus 1. This is what I will get. This is 1. Okay, so we have derived the signal. So the signal this will extend to infinity, negative infinity, and here it will extend towards positive infinity. Okay. So let us take another example. Let us try to sketch negative of u of t minus 1. So I know what is the u of t. So u of t is like this. This is u of t. So if I then this will be, I want to delay it by 1 unit. So my signal will be like this. After this, I want to multiply this the signal with the negative of 2. So when I multiply the signal with negative of 2, the signal gets reflected on the x-axis. So the signal becomes something like this. Okay. So this is negative 2. So the amplitude of the signal becomes negative 2, and this becomes negative 2 t minus 1. Okay. So let us take one more example. Let us try to sketch r of, third example is like 3 times r of t minus 1. I know that r of t minus 1, the ramp signal is something like this. Okay. And it is having a slope. The slope of the signal is 1, is equal to 1. So when t is equal to 1, the amplitude will be negative, will be 1. Okay. Now let me derive r of t minus 1. So the r of t minus 1 will be shifting this signal in the forward direction by, this will be r of t minus 1. Okay. And let us say at 2 the value will be 1. Now I will have to derive 3 times. I have to multiply this signal with 3 times. That is, the slope becomes 3 times now. When the slope becomes 3 times, let us say this. So this here it will be 3. Okay. So this signal is 3 times r of t minus 1. Right. And let us take another example. Let us try to derive another signal. Now let us say we are having negative d plus 2. That is, I know this is r of t. and I know that this is r of negative t. This is negative 1 here and it is 1 here. Okay, so it is, let us say it is 1 here and it is 1 here. Now I have to advance this by 2 units. So when I advance this by 2 units, the signal will become like this. This is 2, this is 1 here, and the signal value will be 1. Now this is r of minus t plus 2. Plus 2. So this is 1 and this is 1 here. So let us take another, the last example. This is the symbol for a rectangular wave. So we are having a, so we know that the rectangular wave denoted by this function, the wave will be something like this. It is having an amplitude of 1, and here it is negative half, and here it is positive half. So I have to advance this by 3 units. That means I will have to shift it in the negative direction. Okay. If it is negative of 3, suppose if it had been say negative t, then for advancing the signal I will have to shift it in the forward direction. But since it is not, it is a positive t here, and since it is plus 3, it is actually advancing the signal, but this will mean the signal will have to be shifted in the negative direction. Okay, so the signal that we will get is, here we'll have 2.3, 2.5, negative 2.5, and here we'll have negative 3.5, and we will have the signal. Okay. So this is 1 here. Okay. So this is how we have actually tried to shift it in the negative direction. So what we have derived is a rectangular wave t plus 3. Okay. So this is about the various operations. Continuing with the operations of the signal, the next operation that we are going to see is the amplitude scaling. Amplitude scaling we have already seen, in fact. Okay, so without actually explaining what is meant by amplitude scaling, we have actually touched upon amplitude scaling in one of the examples that we have just now discussed. Suppose we are having a signal, let us say u of t. The signal will be having an amplitude of 1, and if this is multiplied by 3 u of t, that is we are trying to scale the amplitude by 3, then we will have a very similar wave shape, but only thing, the amplitude here will be 3. Okay, so this is called amplitude scaling. Okay, now let us take another let us try to understand another operation which is known as time scaling. Time scaling operation. Now in the case of time scaling operation, Let me illustrate this with an example. Suppose I am having a signal something like this. Let us say we are having 0 here, and let us say we are having 2 here. Let us call this signal as x of t. So time is now being scaled. Okay, we want to do a time scale. Let us say we want to multiply the, let us say we want to derive a signal x of 2t, that is the time is actually multiplied by 2t. This is called, we are trying to scale the time. Okay. Now we want to derive this signal. How is it going to be? So the same signal, what we have to do is we have to divide the time the time value, that is 0 by 2, and also the 2 by 2, but the amplitude remains the same. Okay, suppose the amplitude here it was 1, we don't have to do anything with the amplitude, it will continue to remain the same. This is not amplitude scaling. Okay, so this will continue to remain at 1, but the time axis, each of the value along the time axis will have to be divided by 2. So when if it is divided by 2, we end up getting, what we will get, we will end up getting 0 here and 1 here. So here we will have 0 and the other one will become 1. Okay, so this is called time scaling. Okay, so suppose if I want to, let us say if I want to derive another type of time scaling, that is instead of x of 2t I want t by 2. In that case, this is our original signal. The original signal was 2 here, and it was 0 here, and the amplitude was 1 here. All that I have to do is I have to multiply this by 2. So if the time is actually divided by 2, then the time along the signal time axis, along the time axis, the time values will have to be multiplied by 2. That means the signal that I will get is 0 and 4. Here it will be 4. One of the vertices will be at 0, the other vertices, and the amplitude of the signal will continue to remain as 2. So okay, at 1 now. Suppose if the amplitude were to be 2, in that case I have to multiply the amplitudes by 2. Okay. Here we are doing both amplitude scaling and time scaling. Here we are doing we are actually trying to expand. So this is called enlargement operation. The previous one is, here we are doing a compression operation. Say the t is multiplied by a constant, then we are doing actually essentially doing a compression operation. So we are actually here we are doing an enlargement operation. Okay. So this is about time scaling. So far we have seen the different scaling and different operations. The first operation that we have seen was time shifting. Then the next operation that we have seen is time reversal. Then we have seen amplitude scaling, and then finally time scaling. So there are 4 operations that we have seen so far. So there are other operations like multiplication and so on, that we will anyway we'll try to take it up as and when we come across those problems. Okay, we'll take some more examples. Let us say we are having a signal x of t. Let us say we are having a signal example. Okay, I think we'll take a fresh page rather than We'll start on a new page. Let us say for the signal, let us say we are having a signal. Let me draw the signal. Let us say we are having the following signal. Let me call this x of t. Here it is 1 here, and here it is negative 1 here, 0. Then we have something like this. Then we have something like this. So here we are having, we have to derive, we will want to derive x of t minus 2. So that means we have to delay this by 2 units. It's very simple. All that I have to do is I have to, this point will shift to this point, and each of the points will further, this will shift to this point, so on and so forth. So the signal that we will get is, so let us say this is 1, 2, 3 and 4. So I'll end up getting something like this. And then I will have something like this. So this is x of t minus 2. Suppose I want to derive x of 2t plus 3. So for this, first what I have to do is, the sequence that we have to follow is, first we will have to advance it by 3 units, and then what we have to do is, we have to do the time scaling operation. So let me first advance the above signal by 3 units. So that means the signal will have values. Okay, let me erase this. Let me redraw. Let us say the signal is something like, will have to be advanced by 3 units, which means the 2 will come at negative 1, negative 2, negative 3, negative 4. So it will start something like this, and then go like this, and then here, and finally I'll have. Now what I have to do is, I'll have to time scale by 2 units, which means I'll have to divide each of the time unit by 2. So when I do that, the signal that I will get is, it will be negative 2 here, then you will have negative 3 by 3 over 2, then it is negative 2 upon 2, then finally it is half. So the signal will become like this. This is x of t plus 3, and this is x of 2t plus 3. Okay, so we have seen this. Let us take another example.